Hey, what's going on, guys? Let's do this problem right here. This question is asking to integrate this one using trigonometric substitution. Now let's see how we can do this. But before we do this, we have to know three things. That is, the first one is when we have x square and a number square, we have to use a tan theta. And when we have x square minus a number square, we have to use a sec theta. And when we have number square minus x square, we have to use a sin theta, right? Now here we have number minus x square pattern. So we are going to use the third one. But before we do that, we have to have number square minus x square pattern. Because of this 4, we don't have that pattern yet. Now we can do something about that, right? So what we can do is, in this case, if we take 4 common, so if I take 4 common, here we are going to have 1 over 4 minus x square, right? Now if you notice, we have that pattern right now, because 1 over 2 square is equivalent to 1 over 4 minus x square, so we have number square minus x square pattern. Now we can go ahead and do the trigonometric substitution. So here we have to have x is equal to a sin theta. A is this number, half, right? So this is going to be half sin theta. So that's going to be our x value. Now before I do that, before I do the substitution, I can take this 4 outside of this one. That's going to give us 2. So I can move this 2 to the front. So we are going to have 2 right here, and 1 over 4 minus x square. So if you square this one, that's going to give you 1 over 4 sine square theta, right? Now we have to replace this dx in terms of theta. So we have to find the derivative. If you find the derivative of this one, this is going to give us half cos theta d theta, right? So this is going to be the derivative. Now we can replace this dx with half cos theta d theta. Now let's see what we can do now. So whenever we have square root, we try to get rid of that one first. So here what we can do is we can take 1 over 4 common. So this is going to give us 2 integral, and if I take 1 over 4 common, we are going to have 1 minus sine square theta, right? And in the other side, we are going to have half cos theta d theta, right? And 1 over 4, if I take square root of 1 over 4, that's going to give us 1 over 2. So I can take this 1 over 2 outside. So that's going to give us 2 over 2 right here. And then inside of square root, we have 1 minus sine square theta. And if you remember this formula, cos square theta plus sine square theta is equal to 1. You know that 1 minus sine square theta is going to be equal to cos square theta. So we can replace this 1 minus sine square theta with cos square theta. So we can get rid of the square root. Cos square theta, and then we have, so this 2 cancels, we are left with just 1. And we have half right here, half cos theta d theta. Now let's continue this one right here, right? Now this half, we can move this half to the front. So half integration, and cos square theta square root, that's going to give us cos theta, right? And again we are going to have cos theta right here, d theta. Now cos theta times cos theta, that's going to give us cos square theta, cos square theta d theta. So here what we can do right now. So in this kind of situation, we have to use power reducing formula, right? Power reducing formula, we have this one. So let's note that one down. Cos square theta. When we have cos square theta, you can use the power reducing formula, that is half 1 plus cos 2 theta, right? So this one is something you can memorize. So here, instead of this one, we are going to plug this one. So this is going to be now half times integral half times 1 plus cos 2 theta, right? Cos 1 plus cos 2 theta d theta. Now again, we can move this half to the front. So this is going to be 1 over 4, and in integration, we are going to have 1 plus cos 2 theta d theta. Now if you integrate 1, that's going to give you theta. So here we are going to have, let's continue this one right here, maybe, yeah. Let's get rid of this one. Okay, so if I integrate this one, this is going to give us half, and integration of 1 is going to be just theta. And if you integrate cos 2 theta, what's that going to give us? We know that integration of cos is sin theta. So if you integrate cos 2 theta, that's going to give you sin 2 theta. But the thing is, when you integrate this one, here we have to use chain rule. Like whatever the integration, you have to take the derivative inside and divide by that one. So here, derivative of this 2 theta is going to be 2. So you have to divide this one by 2. Now that's going to be our integration plus constant. But our original format was in terms of x. So we have to write this one in terms of x, right? Now let's see how we can do this. So first we have this value right here. X is equal to half sin theta, right? So what we can do is, we can write sin theta is equal to 2x. I just rearrange this equation. Sin theta is equal to 2x. Now what we have to do is, we have to take a right angle triangle, and if you put a theta right here, and we know that sin theta is opposite over hypotenuse, so opposite is going to be 2x, hypotenuse is going to be 1. Now we have to find this missing side, right? So to find the missing side, we can use Pythagorean theorem. We know that Pythagorean theorem is 1 square plus, so actually 1 square is equivalent to, so this 1 square is equivalent to opposite over opposite plus hypotenuse square. So this is going to be 2 square x square plus a square. Now from this one we can derive a square, that's going to give us 1 minus 4x square, right, in square root. So that's going to be our a value. So a is equivalent to 1 minus 4x square root. Now we can write this one right here. So this is going to be 1 minus 4x square root. Now replacing theta is easy, because sin theta, if sin theta is 2x, theta is going to be sin inverse 2x. All we have to have is a representation in terms of x. So here we can replace this theta with sin inverse 2x, and sin 2 theta, we have to do something about this. And if you remember, sin 2 theta is equivalent to 2 sin theta cos theta, right? You can express this one as 2 sin theta cos theta over 2, and also we have a constant right here. And let's see what we can. Now we know that also this 2 cancels. Now let's see what we get. We have 1 over 4 common, and sin inverse 2x, and then we have sin theta. Sin theta, we already know that's 2x, so we can plug 2x right here. And cos theta is going to be adjacent over hypotenuse. Adjacent is 1 minus 4x, so this is going to be square root of 1 minus 4x, and then hypotenuse 1, so we don't have to write that one. So this is it, plus constant. Now let's do the simplification. So let's write the final answer in different color, right? So we are going to have, if you plug this one right here, we are going to have sin inverse 2x over 4 plus, if you multiply this one by 1 over 4, this is going to give us just x times square root of 1 minus 4x over 2, right? Because we cancel one of the 2, plus constant. So this is our final answer. Actually this is 4x square, because we had a is equal to 4x square right here, right? So we had to put this one right here. So let's write the final answer. bigger maybe. So let's write this one here. So this is going to be sine inverse 2x over 4 plus x square root of 1 minus 4x square over 2 plus constant. So this is our final answer. I hope you guys find this video helpful. See you next time.